Hello. Welcome to a coding challenge. In this coding challenge, I am going to attempt something called breadth first search. Now, this is an example, an implementation in P5.js of breadth first search. It comes directly from this book, Grokking Algorithms, by Aditya Y. Bhargava. It's a wonderful book. I highly recommend it. Buzz Marketing Books here on my YouTube thing. But I do want to thank, that's where I learned more recently about this algorithm, and in practicing it, implemented the example. So what is breadth first search? So this video, first of all, is also placed in a series of videos about graph systems and search algorithms. So you can, in this video's description, go back to some of the introduction videos that will lead you up to here. But you can also just be here right now, because I'm going to do everything from scratch with no knowledge. But a graph system is a system of nodes and edges. And you can see here are the nodes. Now the nodes all have a name. These names are exactly the names in the Grokking Algorithms book. And they have edges, so they have connections. You can think of this as maybe a map of friends and their relationships. You could also turn this into more like a maze type thing. There's so many different ways you could sort of visualize this idea of a graph system. And you'll see in some future videos that I actually made previously, I do have some implementations of graph systems to create mazes. But that aside, what breadth first search is designed to do is find the shortest path between two nodes. And in something like this, it's quite a simple problem to eyeball it. We can see, like, if I want to get from you or me or whoever this person is to Tom, I can see through Claire there are just 2 steps. If I want to get to Anuj, this through Bob is faster than going through Alice, Peggy, Bob, Anuj. So how do you figure this out? It's called, one algorithm for doing this is called breadth first search. And the reason why it's called breadth first search rather than something else that you might have learned about or see in a future video called depth first search is breadth first search by definition looks at all the nearest nodes first, sees if it finds what it's looking for, then looks at all the nearest ones to those first and sees what it looks at find for, as opposed to going all the way through. I recently made a video about binary trees and search trees. That's more like depth first search, because in the binary tree you just keep going to the left all the way to the bottom. But here, breadth first, we're looking at the nearest neighbors to start. Okay, so what's the problem that I'm going to work with today? You may or may not be familiar with, I don't know what this is, a thought experiment, a weird idea, 6 Degrees of Kevin Bacon. There's actually a website, it's called Oracle of Bacon, and I'm going to go to it right now. And I don't know, I need an actor, or I need an actor. Let's pick Amy Schumer, and I'm going to pick find link. Okay, Amy Schumer has a Bacon number of 2. The shortest path between Amy Schumer and Kevin Bacon. Amy Schumer was in the movie Trainwreck with Marissa Tomei, who's in the movie Crazy Stupid Love with Kevin Bacon. So this particular website has a massive database of movies, casts, and uses breadth first search to find the shortest path between 2 actors. And the thought experiment here is that Kevin Bacon has just been in so many movies that anyone could be within 6 degrees of Kevin Bacon. I don't think I have an IMDb. What's the chance that Kevin Bacon to Daniel Schiffman? Nah, infinity. Infinity, we got to work on that. Come on, help me out with this here. I want my Kevin Bacon number to come on down. Okay, so how are we going to do this? Now, I would love if anybody, so this is an experiment. I'm going to do this for you and hopefully teach you something about this, and then maybe you could do something similar but with a different data set. But I'm going to use just a toy data set essentially. I manually created, before coming here, right now, this data set. So this data set has a few movies in it, some of which have Kevin Bacon in it, and some of which don't have Kevin Bacon in it. It's organized in JSON format, which is JavaScript object notation. I do have some video tutorials about that if that's unfamiliar to you, but I'll try to talk about that a little bit as I go through. So let me move over to the whiteboard to figure out how we're going to work this out. So what I need to do in my program, we're going to look at the algorithm itself on Wikipedia and start translating it into code. But before we even do that, what I need is I need a node object. So in the end, there's going to be Kevin Bacon, there's going to be some movie, and there's going to be some other actor. So, and then there's lots of other stuff. So in order to keep track of these, what I need is I need some sort of object. I'm going to call it a node. And that object needs to have what you call a value or a label. We're going to say a value. It also needs, each object needs to keep track of its edges, which other nodes is it connected to. So we need edges, and this will be an array. I don't like these dashes here. They look like minus signs. So I don't know. Dot. That looks like something else. But anyway, this is the data. Now, at its core, this is very similar to my binary search tree that I mentioned, which each node just has a left and a right. But here, each node could have just 1 connection, 0 connections, 10 connections. Now, there's other pieces of data that the node is going to need. And these are part of the breadth-first search algorithm. I'm just going to mention them right now, since while they're in my mind. One is we need to know a Boolean. Has it been checked, searched or not? Like, is this, we're looking for Kevin Bacon. Is this node been checked already to see whether it's Kevin Bacon or not? So this is going to be true or false. This is going to be a Boolean. And we're also going to want, eventually we're trying to solve for that path. So we're going to have nodes keep track of their parent. Meaning as I'm checking and moving about through this graph system, I want to keep track of where I came from. What was the previous node, so that when I find Kevin Bacon, I can back up and find that full path. So I want to keep track of the parent as well. Okay? So we know we need an object that stores all of this stuff. So let me come back and start building that. And I'm just going to put that, so I have a JavaScript project set up. If I go to the browser and refresh the page, there's nothing on the page, but I'm going to start adding some code. So first thing I'm going to do is I'm going to write a constructor function for a node object. And I'm going to say this dot value equals something. We needed that. This dot edges is an array. This dot searched is false. It hasn't been searched. And this dot parent, I'm going to just set it equal to null. So I want to be able to, whenever I make a node with this constructor function, even though this, by definition, its parent would be undefined, I'm going to explicitly set it to null just so I'm kind of keeping track of that. OK, so this is pretty good. This is pretty good. OK, first of all, this shouldn't be blank. So maybe when I say new node, I'm going to give it a value. OK, so this is good. You know what I want to do? I want to take this code and I want to put this in a file called, I probably shouldn't call it node.js, should I? Fine, I'm going to call it node.js. OK. OK. So now Sketch doesn't need it. So in P5, P5 has a setup function. Setup function is kind of like window page loaded type thing. So that's going to be in Sketch. I'm also going to make, here's the thing. I'm going to make a graph object. So I might have some redundancy or some things in my code, I'm sort of out of the picture here, that are a little bit unnecessary. But what I would like to do with the graph object is I would like to store an array of all the nodes. And then I would of all the nodes, and I probably need, you know what the graph really should be as a data structure? It would be something like I could look up each node by its, I'll call this a graph by its label, by its value. So this would typically be something like, a hash table where the key might be Kevin Bacon. And then I could, with that key, I would find out all of its edges, its parent, all that other stuff. So I want to be able to have, I might not need this array because I couldn't always, the whole point of the algorithm is to traverse the graph to find what I'm looking for. But it might be useful to have this array if I want to visualize it or do something that I could just iterate over all the nodes really quickly. There's going to be some redundancy here, but this is what I'm going to do. So let's go and do that. And I look forward to hearing from everybody later about how I'm not doing this correctly. I'm going to say function graph. This dot nodes is an array, and this dot graph is an object, an empty object. So if you're going to use this object essentially as an associative array or a hash table, and I have a video about that if you're interested. OK, now I need to read the data. That's the first thing I need to do. So I'm going to use P5 has a function called preload, which I can use to, I'm just going to say var data. And then I'm going to say data equals, and this is a P5 function called load JSON, where I can just pass in the name of my JSON file, which is kevinbacon.json. Kevinbacon.json. JSON. What is it? Somebody will tell me. I'm pretty sure from the comments that it's GIF though, and not GIF. I've been told that many a time. Okay, so now I'm just going to, in setup, I'm going to say no canvas. P5 makes a canvas by default, but I don't need it. And then I'm going to console.log the data. So let's just make sure the data is there. And we can see there it is. So the data came in. I have an object which has an array called movies, and each movie has a property called cast, which is an array of all the actors. So that's great. So now what I need to do is I need to make a node for every movie and every actor. Okay, so I want to be able to parse through and read this list. So the object has movies. So I'm going to say var movies equals data.movies. Then I'm going to loop over all of the movies in that JSON file. Well, I'm really not on to breadth first search yet. I'm just kind of gathering the data. And I'm going to get, and what I'm going to do is I'm going to get the movie equals, and what was the movie? The movie has a cast and a title. So the title is also a node. So I want the movie, it's movies index I.title, and cast equals movies index I.cast. So first I need to make a node. Var n equals a new node, movies index I.title. Okay? So, oh, actually I don't need to say that again, movie. So I need to make a movie node, and then what I want to do in the graph is I want to say, I'm going to make a graph object. And then, right, the graph object is the thing that's going to keep track of all the nodes. So I need to say at the beginning, graph equals new graph. And then what I would like to do is add this node to the graph. So I want to take this node object, whose value is a particular movie, and add it to the graph. Graph.add node n. Now, can I just do this and get this to run? Ta-da! No, graph is not defined. Okay, so first of all, I forgot a bunch of things. One is I forgot I need to add a reference to my node object JavaScript file and the graph object JavaScript file. So that's one problem. Number two, add node is not a function. This doesn't just exist. It's a function that I need to write. So I'm going to attach a method to the graph object using the prototype. I have a video about what prototype is, if that's not familiar to you. Graph.prototype add node equals function. Okay, now what comes in? A node. So what do I want to do? Okay, so I need first a couple things. One is I want to say this.nodes.push.node. So any node that comes in, I want to put it in the array because I want to store all the nodes in an array, which might be unnecessary, but I'm doing that as a safety mechanism. Then I also want to have a lookup of the node based on the name. So the movie name needs to be the key for that node object. So this is going to look a little bit weird, but I'm going to say title equals n.title, no, dot value, right? The title is stored in the node's value. And then I'm going to say this.graph index, that title, equals that node. So this is me this is node into array and node into, it's not really a hash table because it's JavaScript, but I'm thinking of it as like a hash table. Okay, so that's good. I've got the, what do I have? The movies. Okay, let's now add the actors. What I'm going to do in this first part is I'm going to add all the data and get the graph set up, and then I'll take a break and there'll be a second part to this video, which will be the actual implement the algorithm. Okay, so now the cast. I need another loop. I can't use I, so I'm going to use j. The cast.length, j++. And now I need to make a node. I'll call this actor equals cast. Cast index I. Yeah, the strings are just there in the array. Let me just console log everything to make sure I'm getting all the, that's correct what I'm thinking here. Okay, so we can see that, oops, I used index I. I'm like, why is it Steve Gutenberg 14 times? Because this needs to be j. Okay. So now you can see that's me iterating over all the movies and the actors. So now what I need to do is I need to say var actor node equals a new node with that actor name, and then graph add node actor node. So just like for every movie, add the movie, then add all the actors. Wonderful. Okay. So now, let's also at the end of setup now, let's say console.log graph, just so we can look at what's in there. And I don't need to console log the data anymore. I feel confident about that. So, whoops. And I don't need to console.log the actors anymore. So let me go here. So this is the graph. You can see it's an array. It's got an array of 74 nodes. And it's also got a whole bunch of objects which all have the actor name or the movie name as the lookup. So this is good. I'm kind of almost there. Like, what do I have so far? I have a graph object which stores all of these nodes. Only it looks like this. I haven't done any of the edges. So what do I need to do? Every movie needs to be connected to every actor that's in that movie. So I need some way of setting edges. So the edges for each node should be a list of other nodes that it's connected to. So let me see if I can do this. So if I'm thinking about this code-wise, what I want to do here is for every actor, and let me call this movie node. I want to say something like movie node.connect actor node. So I want to connect the movie to the actor. And the other thing I want to do, though this is a question that comes up with these kind of algorithms, does the graph only go in one direction or do things go in two directions? So in this case, I want to be able to go in either direction. So we need to add this connect function or add edge. Maybe I should just call this add edge. Because I have add node, now I have an add edge function. Okay, here in node, so now I want to add to the node object a function called add edge, and it gets another, I'll call it a neighbor. And then I just want to say this.edges.push neighbor. Simple as that. All I need to do, push the neighbor. Now hold on a second. We've got a problem. I just realized we have a problem. The whole point of this is that actors can be in multiple movies, right? So here I am, always, always, always making a new actor node. Now, I know I can't have two instances of the same movie in this data set, but I could have two instances of the same actor. So whenever I go through the cast, I need to figure out if the node already exists. If the node already exists, I shouldn't make a new node. So I want to say if graph contains actor, then actor node, so I want to say var actor node. I'm just going to set an actor node to null for a second. If graph contains the actor, then I want to say graph.getNode actor or something. You know what I could do? Is I could say var actor node equals graph get the actor, get node. So I could just have a function that says get node, and that function will return null if the actor is not in there. So then I could say if actor node equals null, then I make a new actor node. So what do I need to add here? I need to add a get node function into the graph. So let me add that. So I want to say graph.prototype.getNode equals function. And what do I want to do? I want to look up, and so this is like a actor. So I want to say, what do I want to say? Var n equals this.graph lookup by the actor. And then return n. So this is going to get undefined, right? It's not going to actually return null. So I should actually say in the main program if actor node equals undefined. Oh, I'm so exhausted. This is exhausting. Are you still watching this video? I need to take a nap, but I've got to finish this. It's getting late. Okay. Maybe you just woke up and are having a nice little sip of tea and watching this video. Okay. So I think this is going to work. I might have made a mistake, but let's take a look. Refresh. Okay. Node.js line 8. There is an error. Oh, this should say equals function. I just had the wrong syntax. So now let's look at this. The node, so let's look at any given node. This is Mickey Rourke. Edges, it doesn't have any edges. So what did I forget? the edges have to go both ways. So this dot edges dot push neighbor and neighbor dot edges dot push this. Both directions. So let's try that again. Refresh. Let's look at just an arbitrary node, Kevin Bacon, which is connected to, what did I just do? Kevin Bacon, which is connected to Flatliners, Footloose, and Diner. And if I look at 0, which is Diner, it's connected to all these other actors, which are also connected to other things. So I think this is right. I'm pretty sure I have the data correct. Anybody want to say otherwise? Because then I'm going to move on to part 2. So now we could actually do the algorithm, right? So it would be really nice if I had a visual example, right? So I will link to this code example as well, which is using a force-directed graph to arrange it. And as an exercise, you could even stop here and just try to visualize this graph. Not the easiest problem. I would love to see your solution. But I'm going to stop, and what I'm going to do in the next video is I'm going to implement the breadth first search algorithm. And when I come back at the beginning of it, if I found any mistakes, I'll let you know.